Welcome back to week 5 of the Cube for All session. The ultimate goal of this session is to teach and learn Kubernetes the simplest way. So we have seen this, we are in the week 5 of this Cube for All session, and in the past sessions, we have actually seen the whole modernization process and what kind of inefficiencies we might face during the modernization and why we need a no-code platform. Then we saw how to install and configure gopaddle Lite, which is a lifetime free community edition, which can be installed on your local environment. We also saw how to modernize and deploy your application onto your local Kubernetes environments in just a matter of a few steps. So now that we have applications deployed onto Kubernetes, we also saw how to monitor and look at the logs of these applications. Now, this week, our objective is to troubleshoot some of the issues that you might face at the time of deploying your applications. Though we want to make Kubernetes as simple as we can, debugging Kubernetes failures is one of the hardest things. And the reason being, Kubernetes uses decoupled, loosely coupled resources, and it gets distributed across different nodes. And there is a lot of infrastructure components which are really complicated, and debugging issues is going to be hard. So what I'm going to walk you through during this session is, first of all, why is it so hard to debug the failures, how gopaddle can help, what kind of resources gopaddle offers in order to simplify this debugging, like activities, events, alert rules, and notification channels, how to troubleshoot a build failure, an application failure, and a cluster or a node failure. Let's start with this, why debugging is hard. As I mentioned earlier, it has a lot of loosely coupled resources. You can get some of these events. So events are a very important resource that we need in order to understand or even know that something has happened within the system. So the events are the first and foremost critical resource within Kubernetes. Right, so we can use some of the default Kubernetes commands like kubectl on a specific Kubernetes resource, say for instance a deployment or a pod, and find out what has really gone wrong. So those describe commands gives you those events, and we can in general look at all the events within the system using kubectl get events. But the challenge with this is that it only gives you the last few or the latest few events, and it has a mix of both info and warning type events, right? So sometimes it may get overflooded with a lot of these info events that you may miss out a few warnings. And Kubernetes does not by default give you a notification mechanism as soon as an event happens. So one of the popular ways of getting notified is to use Prometheus and use its Prometheus event exporters within the cluster. So you can integrate that with other dashboards like Grafana, or you can have your own automation in place. However, this requires a lot of configuration, and you may have to set up all these event exporters and do integration with other channels. Like if you want notification on Slack, you have to see how to grab those events and then integrate it with Slack. Another complex aspect to consider is the correlating these events with the actual failures. So if something changes in the underlying infrastructure, it can also lead to some of the pods or applications going down. So how do we really find out what caused the issue? So there are a set of these events that are listed, which you can find out if you go to, like if you do a simple Google search on a particular issue, you would find a lot of information around that. But in an initial outlook of these issues, it's difficult to find out the actual reason behind those failures. And some events are false positives, in the sense, even though those warnings are reported, it may be an intermediary warning, and the system can automatically heal and then bring up new instances of these pods or applications, and then again the application may go back to running state. So some of these warnings are really not problems as such. And the last, but not the least amongst this, is that you have lots of information that are available. However, you may have to go to multiple dashboards and metrics and logs to see, and then correlate all of these information to find out what is really going wrong within the system. So these aspects make Kubernetes debugging really hard. So how gopaddle helps in this process? So gopaddle by default brings up event exporters, and it also parses all these event information in an time series database, and it parses this information for a week by default, right? So you can see a history of these events to find out a pattern, or even it also gives you this segregation of these issues to say, okay, this event happened for this application or a pod or a node. So that way, you can categorize the issue and also see a time series data information on the pattern amongst these issues. Sometimes these events are triggered because of some user activity. So you can also see all these user activities and system generated events to see the correlation between these. So say for instance, a user goes and updates the build or a container image, and that in turn could have triggered a few events in the system. So you can see who did what activity and what kind of a system event it has triggered. So you can kind of correlate these activities and events. You can set up fine grained alert rules saying, okay, if something goes wrong, then notify me on Slack or PagerDuty or some of these notification channels. So all of this are pre-built into the system. You can view all of this information along with logs, events, and you even can make those changes from a single dashboard. So for instance, if you look at the right side, so you need user activities, you need system events, along with application and node metrics and logs. So gopaddle gives you a consolidated view of all of this information from a single dashboard. So let's take a look at some of these resources which are offered by gopaddle, right? So you have these activities. So activities are triggered by the user, which in turn, acts upon the Kubernetes resources. And when something changes within the Kubernetes, that state changes, and that can trigger an event. Similarly, a system itself can actually trigger a change in the state of the resource. For instance, a node can go down, or it can automatically scale up, or the disk space or a CPU or memory can usage can go beyond the threshold. So those kind of events are system generated, and those state changes, they result in a Kubernetes resource state change, and which in turn can lead to an event. So whenever an event happens, gopaddle has an event and a rules engine which watches for all those events, and then you can set certain alert rules which says if this event happens, then make a change or notify these particular channels, right? So we call them as notification channels. You can send alerts or notification to AWS SNS, Slack, or PagerDuty, or even you can integrate with other webhooks like Jenkins, for instance. So you can use these events for creating your CI/CD pipelines as well. So let me show you how this looks like within the gopaddle dashboard. So you have, in fact, created your own installed gopaddle Lite in your environment, and you have your gopaddle dashboard with you. So you can, if you have not installed already, you can go back to week 2, where we have shown you the steps of installing gopaddle Lite in your environment. Now, today I'm going to show this example from the portal, which is our SaaS version of gopaddle, but however, you can say the same sort of support in your local environment as well. So I have a project here called gopaddle Lite. The projects give you some isolated environments where you kind of a multi-tenant environment where you can have multiple projects and manage them in isolated fashion. So I have a project called gopaddle Lite demo, so where I have set up these demo environment today. So this is the dashboard, and you can see all kinds of metrics. We have gone through these last week in week 4. So today our focus is on the alerts and events. I will be running through all these events in a while. Let's go back and take a look at the Slack and the PagerDuty notifications. You can see that there are 4 different types of notification channels. So Jenkins, Slack, PagerDuty, and AWS SNS. So we have configured something around Slack and PagerDuty. So there are around 68 events that were sent to both Slack and PagerDuty. So how we configured these and what kind of events were sent, we will take a look at it. Under the alert section, you will see 2 categories. One is the notification channel, and other is the alert rule, right? So notification channels is where we go and set the notification channels like HTTP webhooks, SNS, or PagerDuty, right? So Slack and Jenkins are a form of HTTP webhooks. So you can choose webhooks and then choose whether you want to have a Slack or a Jenkins URL, right? So if it is Jenkins, it is going to be a Jenkins job URL, and in case of Slack, it would be a Slack webhook. So you can actually go to the Slack website and see how to create a webhook URL. In case of Jenkins, you can see in our help document on how to create and use Jenkins jobs URL. So if you go to the gopaddle CI/CD pipelines, you can see how to create those webhook URLs, right? So you will have some endpoint like this. So today's discussion is mostly around alerts. So once you create these notification channels, similarly, you can also have SNS. So for SNS, you need to create an IAM user with specific credentials or the permissions. And you will find more information on this from the help documents again. So if you go to AWS SNS, you will find what sort of permissions you need in order to register an AWS SNS IAM user. So you have more information on how to create PagerDuty channel, how to create an SNS channel, and what kind of a webhooks have to be created. So it has pointers to creating a Jenkins webhook as well as for Slack webhook. So once you create these channels, the next step is to create an alert rule. So this is where we have many types of alert rules. Let's walk through those before we come to the demo, right? So activities, right? So these are user generated activities. So these are very specific to what kind of activities a user performs from the gopaddle dashboard. So activities can be acted upon multiple types of resources. So it can be a build, application, or a cluster. For instance, the user creates a build or triggers the vulnerability scan on a build. Similarly, for application, a user can perform a service rolling update, or roll back to a previous build version, or update a volume configuration. And this service image secret update is something that is done by gopaddle. So if you have deployed something onto Kubernetes, you may have used a private registry, and you may need to rotate those tokens for pulling the images from a particular Docker registry. So gopaddle does this automatically once in a while, and every time it updates the image secret, there will be a notification saying, service image secret updated. Similarly, application delete or a purge can happen by the user. The cluster, the user can create or update a cluster, or delete a cluster, or even create, update, or delete a node pool. So all of these activities are user driven activities. Events are system generated, and this is where there are a lot of events that get generated gopaddle only looks for the warning events, and especially when it is sending the notifications. However, all these info events will be visible in the corresponding application activities or the events page. So the notifications are sent when you're creating a notification. Only the warning events can be watched and notified. So for applications, again, gopaddle has three categories of applications. One is the user application. The add-ons are the add-ons that are deployed by gopaddle onto the Kubernetes environments. For instance, the Prometheus event exporter is an add-on. Similarly, Grafana is an add-on, right? So those kind of add-ons are also a sort of applications. You can set events, and how you want to get notified for each of these events can be configured separately. And similarly, for kube system services that are running on the cluster, you can set different types of notifications. But for each of these applications, whatever you see on the left hand side, like the pod, container, these are the different types of categories or the categories of events that are supported by gopaddle. So for instance, the pod event happens whenever a pod gets deployed. A container event, for instance, it can result in a back-off scenario when a container is started and it failed. Now, similarly, the image event can be a back-off again if the image cannot be pulled. A config could be like whenever an environment variable name is updated, a new environment variable is added or to the deployment spec. And if the environment variable does not follow the naming conventions supported by Kubernetes, you may see some config events. Scheduler happens when you want to schedule or deploy, or it's trying to place, Kubernetes is trying to place a particular pod on a node, and it's not able to schedule that node, right? Lifecycle hooks may be whenever a pre-start or a pre-start or a post-start event of a pod gets failed. Replication controller, again, a scale up or a scale down event can result in a problem. Probe usually happens when your health check scripts are not set properly. Ingress happens when this is a specific event, again, supported by gopaddle. So whenever you're deploying your application with an ingress, if there are any ingress related issues, then it gets reported under the ingress category. Load balancer even happens when you are not able to provision a load balancer, and there are no sufficient nodes to provision those load balancers, then you get these load balancer events. Similarly, on the cluster side, you have a node or a volume or a network or a load balancer issue that may be due to the cluster specific issue. For instance, the node may, there may be insufficient capacity, or volume has, when you're trying to mount a volume, it may have some permission or a network issue. Similarly, a CNI plugin may cause an issue. So these are the different types of categories of events that are reported by the Kubernetes system, and you can go and set these events in your alert rules. For instance, let's go back to the gopaddle dashboard here. So you can choose the different types of events or activities. So for instance, for build, you can create an event saying, choose the container under which you want to create an event or an alert rule. And then you can select the events like build, created, or scanned. Similarly, if you are setting an application event, you can choose the application category and then add a event here. So you will choose the application for which you want to get notified and what type of events. Now here you can see all categories, right? So these are application activities. Similarly, under rolling update activities, you will see all kinds of activities. Under volume events, you will see different types of volume events that you want to watch out. And the corresponding reason for triggering these events. For instance, we can actually take a look at this volume mismatch, right? So this tells you volume size or a class is different from what is requested in the claim, right? So you have used a volume with a service or a pod, and that volume size is different from what you're trying to claim. So this is one such example, right? So you can choose what type of events you want to watch out for. And then once you choose the event, if you want to say, select a particular category of events, say I want to get notified for all these volume events, you can just select all these volume events. Or if you want to choose one specific event, you can just select one of these events, right? So you can select these events and then say, okay, get notify me on either PagerDuty or Slack, right? So we have configured such kind of events. Let's go back and then take a look at the pre-configured alert rules. For instance, as and when a new build is completed, this is going to send an alert to PagerDuty and also on Slack, right? Similarly, there are other events for applications as well. Say for reader app application, as soon as the probe warning happens, you can send the alert rules to PagerDuty and the Slack. So I want to show you some of the sample notifications that you would receive. So for instance, this is a PagerDuty notification that we got because of a reader unhealthy event, right? So unhealthy readiness probe failed. And you will get to see the description in a much more granular fashion. So on which cluster and what is the exact description or the message and what is the state. So it says a pod of this type, that is a reader 0, has failed readiness probe, right? And you can look at the status, and the name of the application is reader unhealthy, right? So all of these you get, and you can also see more detailed JSON output using the detailed log entries view. So you can see the complete JSON input that you received from gopaddle onto the PagerDuty. Similarly, for Slack, you will also see the alerts. Say, for instance, if as soon as an application back off happens, or in our case it's unhealthy, so you will get to see these events. So similarly for build, you will know, see a service rolling update has happened, what is the logs, application updated successfully, and what is the comment that the user has added at the time of performing a rolling update, and then what is the start script that was used, and which is the service and the container, right? All of these information are captured in the notification. And your teams, when you're especially when you are working as a team, you can configure and find out what is really happening to the system in a live manner. So let's go back to this and then start taking a look at a few build failures. So as I said, like, some of these events can happen due to a build or an application event, or because of a cluster event. So where to look for information when something failed, right? So you can, in case of a build, gopaddle gives a set of build activities. Similarly, you can also take a look at build logs. Since the container builds are happening on a Kubernetes environment, we may also have to take a look at the node metrics and the node logs. So let's take a look at an example, one or two examples around the build failures. So you can see all these builds under the builds category. So I'm going to take a look at this build number 8. Okay, so build number 8 has failed. And if we look at the activities, it says 0 to 2 nodes available to insufficient memory, right? So which says that for building this container, there is not sufficient memory on the cluster. So what is the capacity that we have allocated for this build environment, right? So for building this container, we have allocated, it says, let me go back. So it says insufficient memory, right? So it says insufficient memory, and we have set it to 8 GB to maximum 10 GB of RAM, right? Sometimes it may also fail with insufficient CPU, where in case, here we have set 1000 to 3000, right? So let's go back to the cluster and see whether we have so much of capacity in order to build this container. So the cluster where this build happened is GKE GP Lite. Let's go to the cluster and see what is the configuration. So we have requested for 8 GB RAM and 1 to 3 virtual CPUs. So 1000 millicore is one virtual CPU. So we have requested for 1 to 3 virtual CPUs. So this is the cluster where the build has happened, and we go to the node pools and we see that there is one node pool with 2 nodes. So let's go to the nodes here. So in the first node, we don't have 3 vCPUs, it's only 1000, and we don't have 8 GB RAM. So the memory is not sufficient to build this particular container. And it doesn't stop here. So Kubernetes is going to schedule this on a different node, which is available, the second node. So even here, we don't have that much of capacity. So it has tried both the nodes, and it has failed, saying that there is not enough memory to build this container. So the resolution would be to go back and then change the build configuration to increase the capacity of the build. So if you look at build 9, it would have succeeded because we have used the right capacity for this. So let's take a look. So we have given, memory requested is only 5. Even though we have given the capacity, increased the maximum limit to 10 GB, whatever we have requested is already there. So it has succeeded, right? So you can see all the build logs and everything here. Now, if for other reasons, right? So let's take a look at the build script problem. For instance, build 10, it has failed, saying, failed on executing the pre-build or the build script. So it was clearly mentioned what is the problem here. So you can take a look at the build logs to see what exactly has failed, right? So it has given a error message saying MVN not found, which means we have to update our build script to install Maven, or we may have to use a base image that has a Maven pre-installed, right? So to know more about how to create these build scripts and what are the strategies for creating a base image, you may take a look at the week 3, where we have actually gone through the steps of onboarding a application and the strategies of preparing the base image, right? So you can take a look at those and come back. If you're facing issues, you can come back to this session and then take a look at these debugging scenarios. Now let's go to the okay, before we move on to the application failures, let's take a look at what other types of build errors you may face and how to where to look for more information, right? So you can actually go to the help document. There are multiple reasons why a build can fail, and this section has actually categorized the different types of errors you may face and what is the reason for failure and how you can resolve those. For instance, sometimes this build may fail, saying preparing the distribution image, and the reason could be because your gopaddle is not able to push the Docker registry due to unauthorized error, right? So in the build logs, it may say unsupported status code body not authorized. So this clearly says that there is an authorization problem, and that is because we are not able to push the final container image to the Docker registry. So how to resolve it? You can actually go back and see whether that registry is registered and the API token is valid. If not, you can go and update the API token from the registry page. So for instance, you can go to the registry and then you can edit it, view and edit. So you can edit your API tokens from here, right? So you have a section to update the API token, update the API token, and then rebuild the container. Failed on preparing, again, in this case, it says your authorized token has expired. So very clearly it is stating that token has expired. So same solution, you can go update the registry and then get the new token and update the registry information in gopaddle. The next is not reachable. So it is failed. It says no errors in log, and this can happen when the cluster is not reachable, right? So if you're trying to build a container and if the cluster is not in running state, then it can happen. And in that case, you probably may want to provision a new cluster and then use that cluster for building the containers. So this is the error that we just now saw, and this clearly says in this case, it will clearly say what is the script that is failing, and you can go change the script and rebuild the application. And this is also the issue that we saw: insufficient memory or CPU, where you have to go back to the node information and then see whether you have sufficient capacity, and based on that you may have to change the build environment details. Out of memory killed. So this happens when your build is consuming a lot of memory. So you have set a capacity. Say, for instance, in our case, we have set the capacity as 5 GB for your build environment, but your application is consuming more memory than what is allocated. So this is your build script basically. So in this case, you may have to increase the allocation capacity to accommodate your build script. Error image pull can happen when your there are multiple reasons why this can fail. So this can happen because of some issues on the kubelet side. So sometimes you may have to just rebuild it, and this is often seen in the first time build, right? First time you are building a container, you may see this problem. So if you just retry it, it may work. But in some cases, it can happen if the build process is, if you are not able to pull the base image for your container. So you have to make sure that the base image is available in the Docker Hub, and you have registered, if it is a private registry, you have actually registered that with gopaddle, right? So these are some of the common build failures. And this section gives you a detailed view of what kind of issues you may face and how to resolve those issues. Let's go back to troubleshooting an application failure. And this is the tricky subject, because now we are looking at multiple scenarios where this can happen, and there are around 33 events, and along with application activities that you may want to take a look at, right? So you have to start the places where you may want to check for information is on the application activities, service, replica, container status, and its corresponding logs. If you have configured an EFK stack, then you can actually look at the specific application logs. You have to look at cluster activities, nodes, and node status and logs. So you have to look at multiple places to find out these information, and gopaddle allows you to check all this information from a single dashboard, right? So let's see some of the application failures. Right, let's go to the dashboard again. From a single shot, you will be able to see these events from this consolidated dashboard. For instance, all these application and cluster events are available from this dashboard, and it also tells you from where it got triggered. For instance, you can see today we have these events logged. You have a couple of cluster events, disk events, Docker events, Kubelet events, and others. So similarly for application, you will be able to find out what some update events have happened, scaling events have happened, and so many others, right? So these events, you can get a detailed view of these events from the details page. Okay, let this load. So here you will be able to find out what exactly has triggered this. Let me go back to the dashboard again. Okay, let this come up. So it looks like some delay. So I'm going to use I've connected my local environment to the portal. So I should be able to see these events here as well. Right, so here you can go to the detailed view of this. Okay, so looks like it's taking time to load. So in the meantime, let's take a look at the activities and how you get notified. So for instance, you can see all these different types of activities. Say for instance, a reader pod is failing with backoff issue, right? So you can go correlate this with other events and activities. So you can see some updates have happened. So somebody has actually so somebody has built it and it has failed, and somebody has updated the application, right? So you can see all these kind of activity. So some multi-port application has been updated, and similar such activities you will be able to see from a single list, right? So similarly, you can. So I have to see whether this gets loaded this time. Looks like the loading is taking a few minutes. So maybe Gayatri, you can check this and let me know once this comes up. We can come back to this session and section, and then we can view the events again.
Okay, sure, Vinodri. Maybe you can do one whole refresh and try that.
Absolutely, yeah. Let's get to the cluster events here. It's just that my okay. We will come back to this. All right. So, meanwhile, from the application side, let's see the different types of issues that we may face. Right. So, under multiport, you can see that the application is in running state, the service is in running state, but still in the under the activities, you can see there is a backoff issue. Right. So, the backoff can happen either because the container is not able to start, or because the image could not be pulled. So let's see what is the scenario in this case. So looks like it is failing with a spec error. So most probably, and it's also saying back of restarting a failed container, right? So it is not able to start the container. So most probably it is something to do with the start script, so or the entry point, right? So we go to the service. The service is in running state. The replica is in running state, right? So it is all ready and it's running. Under container, this is also in running state. So we don't have any issue. So it's absolutely fine now. But however, if
Vinodri, I think you are
we have
using your
reverted the
local
change.
host. No, no, no.
Okay.
Actually, you are using the local host. No, in that it won't work the like terminal and the build logs.
Yeah.
So
Let me go back
since
to, yeah, looks like we've been trying something and we have not reverted it. No, let me go to the portal here. Right. So let's go to the multi-port here, and you will see the services in running state. So if I change anything in the um, artifact, so if I say, for instance, we were trying out a few things and we reverted it back. So that's why it is in running state. So let's take, for example, if I remove this, I'm just changing the binary name that has to be executed. Okay. So I'm inducing a failure. So we should be able to reproduce the same issue, right? So here the start script is incorrect, and this is going to again induce this back of container issue. At the same time, we also have a health check which actually looks for it executes this curl command, and it is expecting 200 status code, right? So since the start script is incorrect, this is going to container is going to fail because the binary is not available, and it is going to exit with a non-zero status code, and this health check will also fail, right? So in that case, let's see what happens here. So it has terminated the previous replica, and a new replica has come up. So under this you can see again.
actually you viewed the old one. The second one is the just good. Yeah.
Right. So here you see that it has actually brought up is bringing up a new replica with our changes, right? And inside that, you can see that it is not in ready state. So this clearly says it's in unready status. And if you go to the container, it is still in pending state. It is the back of restarting, right? So it clearly says that it is restarting a failed container. And if we look at the current logs, it says that this binary is not found because we have changed the name, right? So how do we rectify this? So it's the other way around. So we have to go back and fix this problem. In order to fix this problem, we need to edit the start script again. Now, some cases it may be even a little more complicated than a simple binary name change. So one strategy that we can follow is to go add a sleep call so that we can log into the terminal and then debug the issues. Now, when I add a sleep, this again may not bring up the container because of the health check. Now, the sleep call is going to wait, and the health check is going to wait on this particular, like it's going to do a curl on this endpoint. Since this endpoint is not available, this may also fail. So we may have to remove this health check and then bring up the container again. So we added a sleep call, we removed the health check, and now this is going to bring up two other instances of replica, and it will finally it'll end up with one replica with all these changes. So we may have to wait for a few more seconds for this particular replica to move to running state. So let's go inside this replica. Still not ready. I think this is not the one. Hold on. Yeah, this is the one. So it has moved to running state. So we go to the container and we see that it is in running state, right? So we can go back to the terminal and then we can do all our debugging to find out what went wrong. So we know that there is only a hello world application here, binary here. So we may have to use this. So in which case we go back and then change the artifact and bring and also add the necessary health check. So let's edit the health artifact again and then remove the sleep call, and we will revert back the start script. So we can also bring back our health check, because without health check, we really don't know whether everything is working as expected. So we will add a health check, and we can add some initial delay and period seconds and add the curl command here. Right, so let's save this change. Now this is going to bring back a replica which would move to a proper running state. So let's go back to the replicas again, and you can see that it is starting and started a few seconds ago. So all of these are captured in the service logs. You can see how many changes we made, and also under the container logs, which we already saw. And all from an application perspective, we can also see all kinds of logs from here, right? So under the activities, we can say what is the update that we did. Say we have updated the start script, we have updated the health check, and every time we did, the system triggered some scale up and scale down events. You can also see some unhealthy status, like we just now did. So it shows 2 minutes ago. So all of this is captured from the application standpoint. Let's look at some other types of issues. Say, for instance, unhealthy services, right? So this comes mostly because of the health check that we have added. So here the service itself is in pending state. So when we go to the replicas, we can find out that it's in unhealthy state, right? It's not ready, and it says that unready status. So the container is in unready status, right? So in order to debug such issues, we have to go to the specific container. Even though the container is in running state, you can see that it has restarted a couple of times, right? So if you go back, you will see it has restarted a couple of times under the containers. You see it has restarted 6 times. So which means something is constantly container is trying to restart and move to running state. So some logs that may be helpful in this scenario are the current logs and the previous logs. Sometimes you may not have the current log because it is still restarting, in which case you can go to the previous logs to find out where it really failed. So this is another scenario or another type of issue. Let's take a look at the volume mismatch. Now this is much more trickier than the previous two issues, because this has something to do with the infrastructure. So as I pointed out earlier, volume mismatch happens when we are trying to claim a volume and the volume that is really attached are not matching. So how we replicated this issue is that, let's see how it looks like, right? So we go to this services in running state, and then replicas in starting state. But you can see pod has unbound immediate persistent volumes, right? When we look at the logs, it has not reported anything specific. If we look at the containers, there are no containers, so it has not brought up the container itself. So the infrastructure, the provisioning itself had some issues, and the reason being, like, we have a couple of volumes. Now this is the volume that is bound. So if you look at this volume, this is the volume that is bound, and it is bound to okay, so this has 5 GI as the capacity, whereas in our when we launched this application, we have used a different persistent volume claim, or the the volume policy, which is the 8 GI claim. So because of this claim and the actual volume that we have attached, so we have attached a pre-existing volume and we use this claim. Because of this mismatch, the volume claim or the volume mismatch error has happened. To rectify this, we may have to delete the application and relaunch it. So this is something very tricky, and we need to know what kind of problems may happen. Right, so there is another section in gopaddle where you can troubleshoot these kind of issues. I mean, you can check, for instance, service stuck in pending state. This is less likely to happen in a local environment. But if there are, like, say, for instance, the number of replicas provisioned on a specific node exceeded the maximum limit assigned to that node. So there is a threshold of how many pods we can bring up in a particular node, and if it has, if the number of pods increase, then you may see these problems. So you can actually go to the troubleshooting section here and then look for different types of errors that you may face, and you can resolve accordingly, right? So for instance, exec format error is another common scenario where you may face, and that's because if you haven't used a hashbang symbol or the hashbang bin bash before your scripts, it may actually fail with exec format error. So these kind of errors are very common and straightforward to fix, whereas anything that has some linkage with the underlying infrastructure can become a little tricky. Right, so let's look at some of the infrastructure or the node related issues, right? So as I said, anything related to the cluster or a node failure are a lot more difficult to debug, and it may actually result in some other issue on your application. You may first see them on the applications. So what you may have to do is to look for cluster activities to see whether any user driven activity has caused this problem, or you can also look at some of the node status and the logs. And if it is if you have any doubts related to the node configuration, you can get the kubelet information. You have to log into the node, you have to get the kubelet information, see the Docker service logs, and also restart your kubelet or your Docker service, right? So let's see some of the common issues and how to troubleshoot them. For example, you can, if you come to the troubleshooting nodes information, node issues, cluster or node failures, we have categorized a few issues here. For instance, the free disk space failed event happens when you have used up all your disk spaces. You're trying to pull a lot of Docker images, and then you don't have enough space in your node to accommodate a new image. So in which case you may have to resize the volume or clean up some space by removing some of the unused Docker images. Usually Kubelet triggers a garbage collection periodically, so that it keeps within the threshold limits, and it looks for all unused images, the last used image or the last unused images, and automatically cleans up those images. But when you don't reach that threshold, and when your image is larger than what it can fit in the node, then you may have to do either adjust the threshold, or you may want to clean up the images manually. So there is a pre-built garbage collection utility provided by Spotify. You can use that, or you can also go back to the specific node and clean up some images. The similar kind of an issue can happen with the image garbage collection failed. So this can happen when the garbage collector itself failed due to some reason, right? So where you may have to free up some disk space, restart the kubelet, and then try deploying or watch out for these errors again. The next issue could be invalid disk capacity. So this happens if kubelet is not able to identify the actual capacity on the node. So sometimes you may have to restart the container D and the kubelet within the environment. Or in some cases, it could be a C group issue. So if you have not set C groups, you may have to set the C group and then reboot the node. There is another typical issue which happens, like the container garbage collection. Again, this is also related to garbage collection, where you may have to, this can happen more often if you have not set the limits for your deployment. So if you have not set the resource request and the limits, then this can happen, right? And even if you set it, you may have to cordon or evict the pods and then reboot the server. So you will be able to find out all these information from the node information, node metrics and the node logs, which I'm going to show you in a minute. And then you can also, in some cases, if you are setting the eviction thresholds manually, then make sure that it is not very close to the physical memory or the physical node limits. So if the threshold and the physical limits are very close, then you may see these kind of events more often. We found one useful link where you can see all kinds of these node related issues and how to troubleshoot them in this particular website, FASKey website. So you have a link to this from the gopaddle help document itself. You can take a look at these in the later point in time. So let's see how the nodes show up and what kind of metrics you can get for the clusters. So let's see what is available to you. Under the activities, you will see what kind of activities we have performed. And under the node pools, if you go to the pool nodes, you will be able to find out for each node what capacity is available, both in terms of CPU, memory, and disk, right? And more information about these nodes as such. How much of capacity is consumed by these Docker images, the different types of logs, another thing like disk pressure, right? So you may be able to see some disk pressure related events also here. So you can find out all of those information here and any event that got triggered, right? So right now there are no events, but you may be able to see those events here, right? There may be, if you are using cluster managed cluster on GKE or AWS, you will get those specific kinds of events as well. So with this, I would like to end this session with a note that debugging Kubernetes failures is tricky, and you need to have different kinds of tools handy in order to debug and resolve those issues. And I hope I have given you enough pointers in this session to know from where you can look for those errors and how to debug some of the issues, common issues. For the one last time, let me retry and see whether this alert gets loaded. So you can go back to
Actually, we just need to wait a few more minutes. It will come.
Yeah, looks like it's taking a few seconds to load. And once you get these, you will be able to see in a time series way, like what application has caused what kind of events. Right, there we go. So you see that a scaling event happened, an update event happened. So what kind of application got updated, how many times? Similarly, you can see a service rollback has happened. And what volume event. So you see that the volume mismatch event has happened for this reader volume application. Some provision event has happened, and what kind of events or those. So similarly for clusters also you will find such information. And I hope you find this session useful, and I hope this helps you in some fashion in debugging your Kubernetes issues. We really look forward to the next session. Watch out for our week 6, where we will show you how to build a CI/CD, rather how to subscribe to a marketplace. And we have a few applications that are readily available, which you can leverage and then build a large scale application using that. And subsequently, we'll also see how to build CI/CD pipelines. We look forward to the next session. Thank you so much.